triangle. Now, one thing you may not have noticed on the top thing, but now I'm going to draw your attention to it, is this. This is the main logical operator, okay? Now, we don't have a title for secondary operators, but let's call this the major operator, or main logical operator, and this one the minor, okay? Notice what happens when we convert this to that. The main operator, or major, becomes a minor operator. And the minor operator becomes the major operator. Okay? The same pattern holds when I'm doing the disjunction. So look, this is the main operator, so it becomes the minor operator, so it's going to go there, and it's going to go there. So this would be or, and this would be or. This is the minor operator, which is going to become the major operator, so it goes there. And that's just an easy way to remember the pattern. Does everybody understand that? So wherever I have one of these, I can make it one of those, or I could go backwards. Okay? So this allows you to manipulate statements that have a combination of ands and ors. Okay. The next one, double negation. This is a rule that we don't really need because of our special notation, the opposite of, okay? That makes things really strong, but many systems don't have it. So you might have not P, then Q, not Q. If I did modus tollens, I technically would get not P, okay? And so other books, other systems will say, so since we have not P, we can say P by the rule double negation, right? But we define modus tollens such that we can do this, not P, then Q, not Q. This is the opposite of that, so we get the opposite of this, and the opposite of that is just P. So we bypass the need for double negation because of this notation. Does everybody understand that? But I'm including it in our list because I want you to be aware that other texts, other systems don't use this. It's less powerful. They're less powerful, so they have to include double negation in order to get done what needs to be done. Okay, and so double negation, where'd my double negation go? Yeah, so if I have a box, that can be replaced with not box, or vice versa. It goes both ways. That's double negation, which is for us not very necessary. Okay. And all of this is in the book. It's in the main line of the chapter, and it's also reviewed again or listed again right at the beginning of the homework section for chapter 5, okay? So those are the places you can find this stuff, okay? The next one we have is transposition, and notice that the operator is a conditional, so this only applies to conditionals, okay? I can flip the antecedent and the consequent. Okay, I can move this to there and that to there, but in so doing, I have to negate them. Okay, so I can change this into the opposite of the circle, then the opposite of the square, or vice versa. Everybody understand that? So if I had something like this, P then not S or T, that could become S or T then not P. Everybody follow that? Okay. Flip the places and you change their sign, as it were. Okay, that's transposition. Okay. The next one is called material implication, but I just shorten it 99 times out of 100 to implication, okay? And it lets us convert a then to an or, okay? So box, then circle. If I want to convert the then to an or, what happens is the first thing gets negated, then, and then the second thing stays the same. Oops, this is supposed to be an or. Okay, and we've been familiar with this from the beginning when we had unless. I said, hey, unless, just do it this way. Box, unless, circle. Some people are like, no, that's a conditional to me. And I said, yes, it is a conditional, but if you said X unless Y or box unless circle, if you wanted to do it as a conditional, it would be if not box, then circle. Which is exactly what we've just shown right here, right? So this should make sense. So if you have one of these, you can convert it to one of those and vice versa. And you know that, using all of these rules of replacement in combination, you can take something that looks like this and end up changing it into something very, very different. Does everybody understand that? Okay, material equivalence. This is the only rule that deals with the biconditional, okay? So let's suppose we have box, if and only if circle. When I was first explaining this to you, I said, imagine we're saying something like this: Fred goes fishing if and only if Barney goes. Well, what does that mean? It means the same thing as if Fred goes, then Barney goes, and if Barney goes, then Fred goes. Right? So if you have this, you may convert it to that. Okay? Or vice versa. So if you end up needing to prove some kind of biconditional and there's no biconditional in the premises, well, you're going to need to go get these parts. And then you can convert it to that by material equivalence. Now, there is another option, okay? Fred goes fishing if and only if Barney goes is the same as either Fred goes fishing and Barney goes fishing, or it's not the case that Fred goes fishing and it's not the case that Barney goes fishing, right? Or I guess I should have written it with our notation, which would be opposite of box and opposite of circle, right? They either go together or neither of them go, okay? So that's material equivalence. Exportation. Suppose I have a conditional like this: box, then circle, then triangle. Okay, to understand this one, let's give some meaning to this. Okay, suppose, look, you want to get into the bar. That means you need your ID and the cover charge. Okay, well, that's the same. So if you have your ID and the cover charge, then you get in, which is the same as saying if you have your ID, then if you have the cover charge, then you can get in. Everybody understand that? So why do we call it exportation? Because see, the circle is in the antecedent, and we did what? We exported to the consequent. Okay? And of course, you can go backwards, right? And given other rules, you could have done this. Oh, and okay, so this is the place where I guess I want to say this. Okay. One thing that's completely different about the rules of inference and the rules of replacement is the rules of replacements are equivalences. So wherever you see the one form, you can change it into the other form, okay, on our rules of replacements, okay? And that means you can apply a rule of replacement on part of a complex statement. So consider this one, and we have the rule COM, right? That lets us flip conjuncts for conjunctions and disjuncts for disjunctions. So I might have this, and let's make it real, P and Q then R. Okay, what I can do is I could do this. I could say Q and P, then R, suppose that's 1, from 1 by COM. So I applied COM to just part of the sentence. Does everybody understand that? Okay? And then I could go on and do my distribution. Here is the problem. You can apply the rules of replacement to parts of statements. But as soon as I introduce this, people go back and they look at the rules of inference, and they start treating them as if they're rules of replacement. So let me show you the most basic mistake that people will do. They'll have something like this, P and Q, then Z. And they'll think to themselves, well, I've got a rule called simplification. P, then Z. That does not follow at all. Does everybody understand that? Right? And so in general, one of the things you should remember is only the rules of replacement can be applied to part of the line, okay? Another way to think about it is this. If you're going to use simplification, think about simplification. People try to do simplification here. The main operator in order to do a simplification had to be a conjunction, right? Look at this statement right here.